Hi, in this one we discuss LeetCode problem 3203. Find minimum diameter after merging two trees. Okay, so there exist two undirected trees with n node and m nodes respectively, numbered from 0 to n minus 1 and from 0 to m minus 1 respectively. Okay, you are given two 2D integer arrays ages 1 and ages 2 of length n minus 1 and m minus 1 respectively, where ages I is equal to ai and bi indicates that there is an edge between nodes ai and bi in the first tree, and edges 2 of I means ui and vi means indicates there is an edge between nodes ui and vi in the second tree. Okay, you must connect one node from the first tree with another node from the second tree with an edge. Okay, return the minimum possible diameter of the resulting tree. The diameter of a tree is the length of the longest path between any two nodes in the tree. Okay, so suppose for this example, go to the example actually. Here two graph are given. This is the tree 1 and tree 2. Okay, now what I have to do, I have to merge, I have to connect these two tree, right, by adding a new edge. So I have to actually minimize the length of the diameter. What is the diameter? Diameter means the, like for this example, like for example 0, this structure is like this: 0 3 2 1, right? And this is 0 and 1, 0 and 1, right? Suppose if I want to connect this by this, okay, then what will be our graph, resultant graph? So this will be this, then this will be this and this, right? This will be resultant graph. So what is the longest path for this graph? This is actually the longest. Anything, this is actually longest. What is the length? Length is the 3, right? And suppose if I want to merge, suppose in this way, like for this, suppose, then what will be our actually graph look like? This will be this, and this will be attached to this. This will be attached in this way. This is the one possible way to connect these two trees. So what will be the actually longest path for this? This. So then what will be the length? Length is 1 2 3 4 4, right? So actually for each edge, actually I can actually try, like one actually try this, then one for with this, then one for with this, got it? Then one for with this, then no, this node to with this node. Similarly for this situation, got it? In this actually, in the brute force approach, you can actually merge, like for if there is n nodes in tree 1 or graph 1 and m nodes in the graph 2, then with n cross m, actually I will check all combination, like for each node I will connect with m nodes of graph 2, then the time constant will be n cross m, and after that I have to check also the distance of that graph, right? So in this actually, this will be actually time constant n square into, to check the distance. This distance will at least take big of n. So this will almost time velocity will be it will give us a theory, right? Got the logic? What actually? So I have to actually optimize this. You got the logic that how actually it's working and what they actually want to do. Now, one observation you will check, like what is the actually current length or current diameter of this graph 1, diameter of graph 1 and diameter of graph 2. If I found out these two, then what is our target? Our target should be like like if I want to, like for this graph 0, this, okay, this, and suppose this is the graph 2. So if I have to optimize the diameter, the connected graph, resultant graph, then what do I have to try that whatever is the connection, like suppose I made a connection between these two. Okay, So it will actually like what is the extreme uh, node, the extreme node, the distance from the extreme node of the this should be actually minimum, right? From this node to this node, this should be actually I have to optimize this, right? This was target. So if I have to optimize this, then our target should be attached the mid of this graph and the mid of this graph. If we connect this, then what will happen? Like suppose this is a one graph, suppose, and this is another graph. If I have to optimize the distance from this to this, suppose I have to optimize the distance between these two, and I have to connect any edge between these two graph. Then what should be our target? Our target should be like this divide equal. Try to divide the graph equally. So then what will happen? From this like A, B, C, D, there are four extreme nodes are there in between two graph. So distance A to C and A to D, then B to C, then B to D. I have to optimize the distance between in these four node. Then what is our target? Our target should be like equally distribute this x, try to x, then y. Then what will happen? The maximum distance will be x plus y, because this will be this, then this. Got the logic, right? So suppose the diameter of graph 1 is d1 and diameter of graph 2 is d2. Then for this combination, then what will be our new diameter? d1 by 2 plus d2 by 2 plus 1. Why plus 1? Because I am adding a new edge here. This will be added. Previously it was not present. So this will be our actually for this combination, this will be our diameter, new diameter. What the logic? Like equally I distributed x, this will actually d1 by 2, and this also distributed divided equally d2 by 2 and plus 1 for this. What the logic? And one situation is possible, right? For this example, suppose 0, 0, 0, 0, 0, got it? And suppose this is also 0, got it? And the graph 2 is look like this. So what is the actually diameter of this graph? Here, for extreme this node to extreme this node, what is the distance? 1, 2, 3, 4, 5, 6. And what is the diameter of this? 1. So for this combination, if I what are you trying? I will try to attach this with the middle one. Then what is the middle? 1, 2, 3. Then 1, 2, 1, 2, 3, 1, 2, 3. So I will try to attach this with this. Right? Got it? This is our new edge. So what is the actually distance for this combination? Like distance will be what? 1, 2, 3, 4, 5. This is actually 5. And this will be 1, 2, 1, 2, 3, 4, 5. This is also 5. Got it? Extreme distance of this resultant gram. But what happened? What is the diameter of this? Like for this node to this node, this graph is still there, this connection. So what will be distance from this? 6. Then what will the diameter should be? Then diameter should be 6, right? But 5 is the new combination, but these are already greater than the combination, right? What is the logic? That time what will have to check? That if anything any diameter is present, like which is actually d1 or d2, which is actually greater than the d1 by 2 plus d2 by 2 plus 1, then our answer should be d1. Got it? And similarly for d2 also it is possible. If d2 is greater than d1 by d2 plus d2 by d1 by 2 plus 1, but then also answer should be d2. And if anything happen like in this actually d1 is 6, that's why our answer is 0. And d2 also possible that d2 is also 10. That time our answers will be 10 actually. Got it? That's why I have to check actually 3 things, like diameter of graph 1, diameter of graph 2, and the logic of divide the equally. Try to divide the equally. So then d1 by 2 plus d2 by 2 plus 1. Got it? I have to find out which is actually the maximum, because if diameter of d1 is greater than all of this, then our answer should be d1, because this is already always exist in the graph. D2 also same. and this is our new combination. Got it? Now for d1 by 2, suppose in our graph length is 5. This is the graph 1. Then diameter will be what? 1, 2, 3, 4. And this is actually 7 nodes are there. 1, 2, 3, 4, 5, 4, 6. So diameter should be 5. 1, 2, 3, 4, 5. Got it? So diameter is 5 means what? If I distribute it by 2, then what will be our value? 2. So actually this is actually correct, not. Because if I want to distribute equally, then I can't divide actually equally, right? Because this is the actually odd length graph is present. So if I have to divide the equally, then otherwise take this, attach the edge with this node or this node, right? Because we can't attach to this edge. Got it? That's why I have to attach this or this. Then what is the actually distance? Like here actually, if I suppose attach this with this edge is with this node, then what is the distance? 1, 2, 3. So then distance 3, and this side will be 2. 1, 2, 3, 2. Right? So maximum distance will be 3 here. That's why I have to take the ceiling value. 5 plus 1 by 2. If it is odd, then it will actually adjust. Got it? So go to the actual code. So I actually first of all there are m edges, m node and n node. How actually m find? They already mentioned that number of edges of they are given m minus 1 and n minus 1. So edges length plus 1, I will get the number of nodes m and numbers of n. Got it? So I will create. I have taken a two graph m length and n nodes. Okay. So I will create the first of all create the graph with the edges for graph 1 with the edges so 1 and graph 2 with the edges 2. Got it? After that, what will I have to find out the diameter of this graph. So how actually I can find out the diameter of a graph? So suppose for this graph, okay. So this is actually a graph, random any graph. Okay. So I have to find out the diameter of this. So diameter of this actually, I don't know what is the extreme level, extreme to node. I don't know. So what actually one approach I can actually follow. So first of all, start with any random node. Suppose with this. Suppose. Okay. Then I can find out what is the like whatever the distance should be. Like this will actually give the leftmost point. Like for this, I will get what this is actually what is the extreme node for this node. So this is a distance is 1 2. For this distance will be 1 2 3, and for this it will be 1 2. This will be for 2. So I will get this node, right? If I start visit, so last node I will get this. So if I start if I will get the first of all get the extreme node. Got it? This. Now again I start the DFS from this. I will get the maximum distance. How? Like from here from this node actually I started the visiting. So I'll go to first this, then this, this. Then what will distance 1 2 3. So I will get 3 here. Then I will get 1 2 3 4 5. I will get 5 here. Here also I got 5. So you can actually check that maximum diameter of this graph is 5. Like how? This, and this. Got it? First of all, find out the one extreme node. Then start the DFS visit or anything. Visit the graph again, starting from that node, extreme node, and I will get whatever the last node. I will get the actual diameter of the graph, right? So that's why actually first of all find out the farthest node, get farthest node for the graph 1. Then I will get the one extreme node, right? Then what I will call, I am calling this function get distance. What I will pass the graph, like what is the graph and the starting node. Starting node I will get farthest node. It will return the one farthest node. I will pass this, and this will give the what is the actually get distance. What is the distance or diameter of the graph? But similarly for graph 2 also, similar case node 2, I will pass the graph 2, I will get the one extreme node, and again I will pass the extreme one, that extreme node, and this will return us the diameter of the graph. Then what will I will check what is the like d1 by 2 and d2 by 2 plus 1. That's why I have done this. Like I have actually taken the ceiling value, distance d1 plus 1 by 2, d1 plus 1 by 2, and similarly for d2 1 by d2 1 plus 1 by 2, and at the end plus 1, and for d1 and d2. Got it? So first of all, go to the each function like make graph. I will create the graph variable and the edges. So I will traverse the edges, and for u and v, I will create the undirected graph. So u will be after at the index u, I will insert v, and similarly for v, I will insert u. Got it? Now I have included one more function, get farthest node. It will actually return the one extreme node. Got it? So I'll start from randomly. So I have taken a queue, and I have started from 0. I can start from any node, 1 to anything. Got it? And I am taken a variable visited. Initially it will be false. Why I have taken a visited? Because otherwise it may possible that we can visiting the same node again and again. That's why. So and visited initially 0, I have set 1 because I am starting from node 0, and last is 0. Last means the last extreme node I will visit. This will be actually one extreme node. So till our queue size is greater than 0, I will run this while loop, and I will pop this, and last node will be the current node. Okay, and for I will check what is the neighbor of this current node. If it is not visited yet, then visit this and insert this into the queue. Okay, and in this way actually what I will get? I will get the last node of the graph. One extreme node I will get, return last. So what is the next step? I will pass the extreme node again in one function. I will get the diameter. How actually? So I know the starting node, right? Similar way I will start the queue. I will take in a queue, and initially I will insert the I here because I already know what is the extreme node, and visited initially it will be 0, and I will set visited I at as 1 because it is already visited, and current is equal to -1, means current diameter is -1. Got it? And till our queue size greater than 0, it will actually increase the I will increase the diameter plus actually, and I will first of all find the like level wise traversal. Why? Because if I know this is our extreme node. So what is the actually diameter of this node? 1. Similarly for this one, and similarly for this node, this will be 2 2. So I will traverse this all of this, then I will traverse this all of this node, then I will go to the next level. In this actually, whenever actually I will reach the end, I will get the actual like it is diameter is 1, its diameter is 2, diameter is 3. In this actually I will go, right? So whenever the current queue, I will first of all level of traversal, you know, right? So I'm just traversing the level wise, like all of these are diameter 1 at a distance 1. This is for at a distance all of 2. In this actually I will check, and I will traverse the neighbor of the current node, and I'll check if it is not visited the neighbor, then I will visit this and also insert into the queue, and at the end return current. Got it? So what is the time closer to this? Time closer of this, like for this, I am traversing each node only once. This is big of n. For this also, I am traversing each node only once, and this is only big of e number of edges. So here actually make graph took big of e number of edges. Farthest node took big of n, and get distance diameter, this also took big of n. So time closer will be e plus n plus n. So it will be big of n. Got it? Got the logic, right? And also understood the code, right? Thank you.